Response video to Holiday with hands in it. Ooh. Yeah, just a hands video. I think I'm actually going to do some of these. Somebody did hands videos, they just play with toys. It seems like a good idea because people don't like other people much. But they like hands. Hands are, less offensive. A hand can, I could even put smiley faces on my fingers. But anyway, I'm not going to do jump cuts. Yeah, so I can do things like that. I could point to things or do things and then say something witty or interesting. But anyway, this probably isn't the best, it's just a little bit too much, distance thing. Anyway, it's physics video, obviously. Response video to Holiday on the subject of matter and energy. And I want to get to acceleration, well, velocity, movement. I want to get to, well, look, the underlying conclusion is this whole perception of matter is wrong. That the one we're taught in school, the ideas that we were given, it's just wrong. I mean, Einstein was right. Matter equals energy, but it's not like energy is somehow converted into matter, and then like there's some kind of change. It's merely that matter is energy. It's the combination, the consolidation of energy. So it just putting energy, trapping it. So I even have the word energy trap. That's what matter is. Matter is an energy trap. And what is trapping basically are these photon things, light and other photons, that can maybe even be there's photons we don't know about on the other, on the extreme end of the cosmic ray kind of thing. Very, very little bits. And that these little bits are what's creating phenomena relative to general relativity in terms of the appearance of a curvature in space. So I could duplicate the space well, the spiral going down, the curvature in space thing that the item falls into the gravity and is bent, by also creating a mass of cosmic rays that come in, and as they get closer and closer to a focal point, to an intersection with gravity, the center of some gravitational body, they get denser and denser, and it is that density that is responsible for the increase in the gravitational impact. As you get closer and closer to that center point, you are being impacted by more and more cosmic rays, and those cosmic rays are reconfiguring the arrangement of matter. So matter equals energy times arrangement. So that would be my E equals mc squared counter composition. And then you could put the times the speed of light squared over here. But it's the arrangement, it's the trapping of photons that is matter. So matter, energy is all there is. And matter just consolidates energy. And whatever attributes energy actually has, is photons actually have, is just magnified in the consolidation process. So you could argue that planetary gravitation is a phenomenon of photons when they're consolidated. That's what happens. And likewise for electrical and magnetic effects, which I also have to explain, but I haven't gone into those yet. So anyway, but that's the biggest of the ideas, so to speak, and the secondary idea to that, okay, that it's all just about photons, is small bits, quanta, and that they cause vibrations, and there's harmonics to those vibrations, and those vibrations are related to their frequency, which is their dumbbell shape, let's say, and time and distance and all this kind of stuff is I'll get into all that kind of stuff, but there are no real fields. Fields are, fields in terms of a force field. Okay, so it's not a force field. It's a field of photons that create impacts on matter that reconvert its arrangement back into energy. And so what I would argue is the implications of this are that when matter's moving, it moves not because of some external forces pushing it. It's moving because it's moving at the speed of light, and that it has a net gain in space that it consumes as each one of the photons moves in a circular orbit. So as the circle moves, the circle just keeps grabbing a little more space, and as it keeps grabbing a little more space, it has a net direction. So some of the photons might be grabbing space in this opposite direction, some might be going this way, some might be going that way. The matter, all of the photons in the matter are moving at the speed of light, and they're all attempting to move in directions, and they're all trapped in these traps. They're caught in spirals by some sort of mechanism that ties them, like I said, themselves, even photons connected to photons, like a double helix is built that way. And that trapping of the photons has, for the matter collectively, the entire substance of material, a net movement. And that's the movement of any object that's moving in space. And once it's in an arrangement, it stays in that arrangement until something changes the arrangement, until cosmic energy or some other thing rearranges the matter to be configured to do something else, to move in some other direction, or to cease its movement. And then you have the impact forces of when two things collide, and the phenomenon where the faster it moves, the less it disturbs what it hits. So I think that's an important little interesting phenomenon to understand too, is that movement creates a disturbance in matter's tightness. So how well matter is maintaining its arrangement, like the orbits of the electrons, which are just a collection of photons, and they're spinning and doing their thing. But all of that has a mechanical arrangement, and that arrangement is disturbed by movement. It's like a vibration, and as it moves, it starts to break down the mechanism of its structure, because as you try to move something faster and faster, there's less and less waste in the system, so to speak. There's less and less non-essential movement of the photons that can actually be made into that extra grab. And so without disturbing the breaking, the bonds inside the matter itself. So once you accelerate matter to a certain speed, maybe half the speed of light, maybe 3/4, who knows. I don't have the math for that one exactly, but the matter itself will start to degrade. And so you could argue that matter becomes weaker in terms of its bonds, the rigidity of it. It begins to melt in a way as you accelerate it, and that's why it has less of an impact on what it hits, in the sense that it doesn't create the fractures and other kinds of things that might be caused by the change in velocity. Obviously, velocity, depending on how it's impacting something, will disturb what it's hitting very much. But theoretically, you could argue there's a scene in X-Men where the guy shoots a quarter into a guy's head in slow motion. But if you actually did that, if you actually shot a quarter into somebody's head very slowly, the impact damage would likely be substantial, because it would create pressure, and the pressure would fracture the skull rather than cut through it. It would tear the tissues rather than cut the tissues, that kind of thing. It's like a sharp knife or a quick knife going through a substance and ripping it much cleaner than a jagged knife or a dull knife or a slow knife. It's like the karate impact thing, you have to have enough speed to fracture the wood kind of thing. Which probably has more to do with the wood than the speed, but I don't want to get into it. It has to do with the bonds that hold the matter together, and which ones are more vulnerable to breaking. The thing hitting the thing accelerated, or the thing standing still. So I guess I'm sort of saying there's probably an absolute speed relative to space. You know, so that although you have acquired different speeds, you don't know your absolute speed relative to the cosmic speed, let's say, or the neutrality of quiet space. So I mean, things that seem to be going faster than other things may be going slower because of the direction and their direction relative to some universal point in space kind of thing. But I don't know if that's terribly important, so I don't want to waste too much time on that. I just want to get to the point that what's happening to the matter, like say in an atomic accelerator, they take pieces of matter like nucleuses of matter, and they accelerate them very fast towards the speed of light. And when they're doing that, it's no longer matter anymore. They're just essentially breaking it back into energy because all the photons are now forced to travel in a straight line. So if you're getting anywhere close to the speed of light, you've essentially broken whatever bonds were creating orbits inside the atom. So you're breaking those bonds. And so first you would end up breaking, if there was an electron, the electron would be knocked off. But you know, the electrons themselves, even if you accelerate an electron, you're going to break the helix of it because it can no longer have eccentric motions of its own because you're forcing it to become linear again. You're straightening all the strings, so to speak, that's woven into it. This certainly could be metaphor to string theory, and if you put strings in the space itself, so if you consider space not a grid, but just connections between photons, and you know, photons that were next to each other during the Big Bang, let's say, and they would fly off in clumps of photons, you know, photon next to 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 photon. Those clumps would fly off and you know, and have their, you know, direction, but the points of the photon, the ends, would still have strings to the point they were broken off of. So if you thought of the initial point of the Big Bang as a perfect order, a perfect spiral of a photon following a photon following a photon following a photon into a giant, but very small, compressed spiral. So no space in between the photons, they're just all following each other in a perfect spiral. And you blew that up, and you blew off bits of those photons. Clumps of the photons would fly into space, and if each one of the endpoints still had a string to the point it was connected to, you could almost argue that as it expands, those strings would pull it back together again. And it would pull it back together unevenly based on how many photons were in each clump, and the strings would start getting all tangled, and you know, you could make a theory out of that. But I don't know if it's necessary to go with that. I think you could still go with the very tiny cosmic ray kind of idea of a very small photon, you know, in size, not in energy. Well, not so very small in constituent part, a quanta, you know, that would be totally undetectable by any instrumentality we have. We'd have no way to detect something really, really tiny in space, tinier than a photon. I mean, a super small photon we couldn't detect anyway, even if it existed. So if you just say that the universe is full of that, and that would account for dark energy, it would account for dark matter, essentially, because it would be the clumping of those small particles. But if they're, you know, if you include those in the diagram of an expansion and then a contraction, it may be possible to create the flow mechanisms, and that's what you could see. So instead of thinking of the Earth as a fabric with a dimple in it, it may be better to think of gravity as a drain, where the water falls into the drain. So the water of the universe would be this cosmic energy, these cosmic photons, and they are pulled into the drains of gravity by a natural pullings, whether you think of it a rubber band string between the photons, or however we, that part I guess I can do some figuring to figure out which one makes more sense. But there seems to be clearly an attraction, you know, static, electrical, whatever you want to call it. But I like the idea of turning everything into a mechanics, so I have to come up with a mechanical mechanism for attraction. because we'd still have to explain why cosmic rays do flow towards whatever this drain is called, whatever this gravity well is created. It's obviously, the gravity well is created by consolidation of photons. So sometimes, somehow, photons, when consolidated into a very dense, very zillions and zillions of photons, it creates this phenomenon of a dense gravity, a dense attraction for more photons. And so that has to be explained as either there is a rubber band, a string of that is compressing them in that direction, or some other mechanism of flow that would cause the photons to flow. So again, we're always stuck with some sort of mechanism that causes this directional attraction. Merely the speed of light itself may have something to do with it. The fact that they're always moving, they have to move somewhere. The fact that they have to have some directionality, and that the directionality might be a mechanism of their rebound, off the densest parts of space, in the sense that you could argue that, well, I'll save that, because that's, you could argue that the smaller bits flew out of the Big Bang faster, or not faster, but they were less retarded in their directionality, more linear. And so because they were more of a straight line, like, you'd almost argue that a collection of photons might have a little bit of a jiggle in it. And over billions of years, the difference in the straight line versus the slightly jiggled line would mean a tremendous amount of distance, and that distance has a barrier, an end point, and it rebounds back, and so the fastest parts of the universe end up coming back and hitting the slower bits of the universe, or some kind of bullshit like that. But I have to think of that. So you'd almost say that the universe could be contained inside a bubble of some kind, a barrier, a reflective barrier. But whatever, I didn't really want to go there with this video, but it's the whole point of these videos is to wiggle fingers. Wiggle fingers. So anyway, what have we done here? Yeah, so what we're saying is the important thing to consider is that matter is energy. It's not that it converts it, it just rearranges it, and it re-releases it. So it can absorb energy into the arrangement, or it can release energy from the arrangement, and that's all that we see as light and energy and heat and all that kind of stuff. Is all part of this vibration and releasing of energy, breaking and giving of energy. Heat obviously has an atomic mechanism, in that photons inside the energy have to be flying back and forth between atoms and vibrating them, causing the movement itself is a reflection of photons vibrating. Photons moving creates the vibration. The vibration isn't something mechanical, like it isn't something it does on its own. It doesn't just sit there and go like this by itself. It goes like this because there's photons inside of the thing that are constantly moving and constantly disquiet. They cannot be absorbed into the arrangement. They will not become part of the Borg, so to speak. So they keep bouncing from atom to atom to atom to atom to atom, and causing slight disruptions in movement. Every time they join the atom, they cause the atom to move a slight degree in one direction, and then they leave the atom and they cause some other atom to move a slight degree in a direction, and so they're just constantly creating this tension, and the rigidity of the connections between the atoms. The atoms are obviously, in solid objects, the atoms are glued quite tightly by photons or something that's obviously connecting them together, so they don't have the option of just flying away in a solid, where in a liquid they do. And so you see the impact of the energy is to create energy in the substance, where in other things you might see the impact of the energy as being photons flying out of it. It gets hot and the photons are released because the the atoms themselves can not move, so the photons aren't maintained inside the structure, let's just say, so they are finally released. Yeah, so and then so this understanding, I think this is another critical bit though, is just to understand that movement is not something that's happening in the space around something. It's not happening because of some, the initial jolt doesn't create something called momentum. Momentum is a consequence of a rearrangement of the matter where the net movement of the light inside the matter has it moving in this direction. So when my finger moves, what's really happening is that the matter inside my finger, on the subatomic level, this whole mechanism, a piece of matter, is being stimulated by the migration of electrons within it, and it's changing its configuration. It's changing its absolute material configuration and making it move, because these, as these muscles contract, the contraction is an electrical force is contracting the muscles, and in doing that, it's because of all the interconnections between the matter and the bonds between it, it's causing the movement, which is essentially forcing a net change in atomic structure. So it's just forcing it to eat space atomically. So it's just the frame rate makes it impossible for us to see what is really happening, but what's really happening is the things moving the speed of light inside my finger move the speed of light in this direction a little tiny bit net. They're really just spinning in circles, but they're spinning in circles and eating space, and they eat space a little bit more in that direction. But like I said, the frame rate is so small then you're not going to see it. So that's something I did say here, is clock speed and frame rate, related to I think Hossler-Day also seeing this as a mechanical system, a mechanism, and that any mechanism sort of has, especially computers, they're a good illustration just because they do have a very necessary clock speed, which changes the condition of the computer. So the computer is really a static mechanism, and it's just statically changed on the clock tick. So when your processor clicks one click, there's one change in all the memory locations, and then it stops, and then it changes all the memory locations. So from its perspective, it's always static. It's only moving one piece on the checkerboard at a time, if you could think of it that way. And the clock speed is the checkerboard, and so it just, instead of you seeing the movement just happens. So it's like that's the atomic frame rate. You don't see the checkers move, they just move. So at one frame they're here, the next frame it's here, the next frame it's here. So from that perspective, there is no momentum. It's a static universe. There is no momentum. There is a state change in the condition of the constituent relationships that things are caught up in, and the obligation, because it must move, it must move from the space it is in. It's like there's a force that forces it to move, and it must fall in some direction, and it will fall in the direction depending on whether it has any string tied to it of attraction. So if the only string that exists is the original string connecting it to its original photon, then that photon will decide its direction, you could almost argue. But that's a little more, that gets more complicated, because then you're going back to the Big Bang and saying everything's connected. Like, photon 768 is connected to photon 769, and the Big Bang, they're blown up, and there's still a string between those two. And that would be the initial state of a photon's direction. It's like instead of a big bang, it was a big pull, and you just pulled the threads of the tied photons, and the threads broke, but they remain. The end connections still have another thread that's tying them together. You could argue like some kind of smaller thread. and that would dictate the initial state or something. But it doesn't matter. The real point is that it has to move. Photons have to move, and they move at a frame rate. They move on a clock tick, and therefore have no such thing as momentum. They have condition. They have circumstantial condition, and that decides where they will, what direction they'll move in. And you can say that that's either a function of the absolute condition of the substrate of the universe, back to the grid work of the universe, or because there's a flow of the universe. So that means there's another cosmic ray or some other thing in proximity to the photon dictating which way it'll move. The space is already occupied, so it can't move to an occupied space. It can only move to an unoccupied space. And that sort of explains reflection in a silly way, just because if photon comes to photon, they have to go in some empty space direction. They can't go where the other guy is, so they're obliged to go somewhere else. Yeah. So that's another concept that will take a little work. So we got to do some work on the, we got to do some work on, this is all the same too. So here's the unification part, is that gravity is just this is the rudimentary force on photons. And when photons are consolidated, they express themselves as the gravity is expressed as a magnetic field, as a magnetic consequence. When they're arranged in a certain particular way, the gravitation will be magnified into magnetism, and likewise the consequence of when the photons are in the arrangement of an electron, they can create an electrical discharge, movement. So it's just movement of photons, and it's movement through these. But that's what connects these things. This is more an expression, gravity, magnetism, and electrical, of the relationship between photons and electrons. That's where magnetism would be the intersection of those two concepts, essentially. But that these are all just net changes in the disposition of matter in terms of its arrangement. So as its internal arrangement of the matter changes, it will express itself as having implications on what we perceive as these forces. Yeah, alright. So I think that's enough for this first video. And yeah, but you get into the time, distances, movement, kind of thing, that's also related to the idea of the discrete checkerboard style universe. That time is distance and distance is time. These two things are obviously related based on the fact that the photon always has to move. Yeah. Alright. So I think that's enough. We'll see again. This part's very important. Matter, the loss of integrity. So the structure of the matter starts to break down, and that's heat. But it's this idea that movement would create such a phenomenon. But the movement has to be substantial enough where you have to start degrading the bonds between these photons inside the atoms before you will have those expressions. But that's the matter moving is likely, I guess the point I wanted to make here is that matter moving is likely matter that has lost some of its integrity. Yeah, it will be weaker in the sense that, well, weaker is that's a dangerous statement. It loses no energy. It's just that now the photons are moving in one direction, and so it will flow through something. You can imagine that if things are going at different angles in different ways, that if you hit that, you're less likely to have it go right through you. But ideally, if you converted all the energy in matter into a beam, that beam might be like cosmic energy or X-rays or something. It'll tend to flow right through you because it has no substance anymore. I mean, it doesn't have the density that it has when it's going in different directions in the crosswise way. That kind of thing. It's less likely to hit something when it's not moving back and forth. I mean, if it goes in a straight line, it's less likely to hit anything, right? I mean, if it's jiggle line, it's more likely to hit something in this field than if it just moves as a straight line, because it's going to spend less time inside the substance. So that's an interesting. You know, you could spend a whole lifetime just playing with that idea, and I don't have a whole lifetime. So anyway, more to come, I suspect. Yeah. Till next time.